So let's talk about an important concept in Java called reflection. And this concept is a little bit difficult to understand. It's more of an advanced topic, and it's necessary though because we are going to need to understand reflection to some degree in order to use annotations. So if we were to break down reflection here, and we're not going to go too far into depth into this topic, we're just going to kind of introduce it and then see a usage of it when we get into annotations. But if we were to break this down to a simple term, what reflection is it's basically just some code that you run that can look at itself or can examine itself, and then it could perhaps even change itself or modify itself while that code is running. So this is kind of a interesting concept. You can imagine some of the ways that you could use this kind of ability to make your code adaptive. And reflection really is a concept of metaprogramming, which is you're programming outside of the normal layer that you'd program at. Java is a statically typed language. So normally we could declare variables and we could declare methods and classes, and our code would have to basically run in some path that we have created. If we created a method, it would execute those methods on the classes and so forth. Using reflection, we kind of step out of that and we say, well, we could actually look at the method and we could look at the parameters that are in that method, and we could do something different based on those parameters. So we're writing some code that operates on some code. This is kind of one layer up. A real good example of reflection is the popular movie, if you've seen it, Inception. And in this movie, the basic concept was that there were different layers of reality, and you could operate on different layers of reality. For example, someone would go to sleep, and then when they're sleeping, they could go into a dream, and then in that dream, they could actually go to sleep and go into a deeper dream. And that's kind of what reflection is in Java. It's this idea that you're coding at this one level, but you could go up and you could step up a level, and instead you could be writing some code that actually operates, examines, and uses code that is in your same program. And this is all possible because Java is running in a virtual machine. It makes a lot of these concepts possible, and you can write some real interesting code that you wouldn't really be able to do without reflection. One caution though in using reflection is obviously it's not going to be very efficient. When you're using reflection, you're basically having to take a hit because you're examining code at runtime. It's not able to compile that code that is going to be executed. So that execution path is not known because it's based on the code itself. So now that we've created our own annotation for printer, let's take a look at how we can use this annotation. And what we're going to do here isn't the best example of how you might use annotations in a real application, because we would really need a lot of different classes in order to do that. But I'm going to show you just kind of how annotations work in this example, and this is a fairly practical example for the case that you might have a printer that you wanted to annotate and you want to be able to detect what the print method is from that annotation. So what we're going to do here is we have our printer, and we're going to go ahead and still load paper here, but we're going to pretend like we don't know what our printer's print method is, that we are going to need our annotation to discover it. And again, this is one of those cases where if we had a lot of different kinds of printers that maybe didn't implement any common interface, but we could make them all kind of conform to an interface that we're specifying through this annotation, that would be a useful way to use this. In this case, we just have one, but I'm going to show you how to do this with just one, and then you could imagine how you could apply this to multiple classes that would have this annotation. So we're going to use reflection heavily in order to do this. The first thing that we're going to do is we're going to take our printer, and we've already loaded our paper. So now what we want to do is call the print method. But in order to call the print method, we're going to need to figure out what that method is. So we need to get an annotation off of our printer. So we can call printer.getClass. And what this does is this gets us the class, basically a class object, a type of our printer. So this is going to give us the actual printer class, and it's going to allow us to basically do operations on that type or on the class itself to basically program against that. This is really that metaprogramming using reflection that we were talking about. So off of class, we have a bunch of different methods here. that we can do. We can grab the constructor, we can grab methods on it, declared fields. In this case, we want to get an annotation, and we can get an annotation of a certain type. We happen to know that on this printer, there's going to be a type called printing device. So we can call get annotation, and we can pass in printing device.class. And what this is going to do is it's going to get any annotations that are on this class that belong to this printer. So this printer class is going to be of type printer, and the annotation that's on it, that's of the printing device class, it's going to return it to us. And for this, we're going to use our printing device, and we're going to call this annotation. We're going to set equal to the annotation that we get back. So in this case, we should get back our annotation that was applied to our printer, which is going to be an annotation that has a default print method of print and a default number of copies of 5. So looking back at this code, you can see that we'll get that annotation, and now from that annotation, we're going to want to call a method on our printer. So again, we can call printer.getClass to get the printer class itself, and then on this, we can call getMethod, and we can pass in here some information to select a method. The string is the name of the method, and then we have to pass in the parameter types, or what parameters that method takes. So in this case, we know that all of our print methods are going to be named something, and they're going to take some kind of number of copies. So off of our annotation, we can get the name of the print method. So we're going to say annotation default print method. So that's going to ask for a method of this name, whatever is specified in that annotation. And then for the parameter types, we happen to know that it's going to be an integer, because we know that our copy method is going to take an integer. If we look at our printer class, we have a print method, and that print method has a number of copies, an integer. So by calling getMethod and passing in this string, which is the name of the method, which happens to be print in this case, because we, in our annotation, said the default method was print, we're going to be able to get that method. And that's going to be stored in a variable of type method. We'll call it print method. And we'll have to import this type. And now you can see we're getting a problem here because we need to have a throw catch here, a try catch. So let's go ahead and click this add throws declaration for now, so that we don't have to clutter this with all the try and catch. Normally you should put a try and catch here, but I'm just going to use this throws instead, just so that this example will be a little bit simpler to read. So now that we have our print method using reflection here, we are going to dynamically invoke this print method. So the way that we can do that is we can call print method.invoke, and then we're going to invoke this on our printer object, because this print method is some data about a method. So this print method has to belong to this printer, which we know it does because we got it off of this printer. So we're going to say invoke this print method on printer, and what do you want to pass into this? What arguments are we going to supply to this print method? Well, we're going to look at our annotation again, and we're going to get default number of copies. And so we'll pass that in to our print method. And the important thing to note here is we're using reflection to do all this. This is kind of interesting that we're able to get the class off of our printer, get annotations off of that, reading this metadata. Then when we have this metadata, we need to get a method based on this metadata. We're using that string that we had passed in order to get a method, looking at our class using reflection. And so we get our method, and then we can dynamically invoke that method on this object, on this printer object, and then pass in the default number of copies that we got from the annotation. And again, this is asking for a try catch. We're just going to do the throws for now. Again, this is not the way that you're going to want to do this in real code, but I'm just doing this to make this a little bit simpler so you don't have to see all the try and catch and exception handling logic in here. So that's really all we have to do. I'm going to go ahead and run this, and if you remember, we have our file IO code still in here, so when we do printer.outputPage, this is going to output this page 4, to a file. So let's go ahead and run this. And we didn't get any exceptions. It ran no output here, but if we go into our temp directory, you can see we have this output page.txt, and it's output page 4, line 1, line 2, blah, blah, and 4. And that's exactly what we had asked for. So notice here that we have created our printer, we've called load paper, we've called output page. We never called print directly. We didn't do this. We didn't do printer.print and then pass in 5 copies. Instead, what we did is we looked at the printer. We said, okay, do you have an annotation of printing device? You do. Okay. Now that we have this annotation, do you have a method that is whatever we specified in the annotation, the default print method, that takes an integer? Okay, you do. That must be your print method. So now let's dynamically invoke this, and we're going to invoke it on our printer class. This is equivalent, this invoke is equivalent to this code, to printer.print 5 copies. But we're doing this all dynamically with reflection. So just to recap real quick, let's look at our printer. Let's see what would happen here. For example, we could change this so that we were trying to do a different method. And this is going to blow up. If we said print 1, 2, 3, and then we run this, it's not going to work. We get an exception here, no such method exception, because you can see here when it tries to get this method, that method doesn't exist on the printer. So we're truly dynamically choosing a method based on this annotation. So this is really the usefulness of annotations, is it gives you that kind of dynamic ability to be able to use reflection to do something on your class based on this extra data that you're providing to this class. So let's go over what we covered in this module. The first thing that we did is we talked about annotations. What is an annotation? We learned that an annotation is basically just some data about your code, and that it doesn't affect your code directly, but indirectly you can affect your code through the use of examining annotations. Then we talked about some of the uses of annotations. We talked about 3 main usages, which were the compiler, using the annotation to do things to help compile your code or enforce warnings or errors or make your code conform to some kind of convention. Then we talked about tooling. We talked about how you could use annotations in tools to generate code, to generate documentation, to execute certain parts of your code, like in testing frameworks. And then finally we talked about using annotations in our actual code. During the execution of our code, we could use an annotation to look at itself and do something. So this could save us some effort. Instead of having to write a bunch of scaffolding code to do something, we could use annotations, and we could write some code that looks at those annotations and is able to basically generate some code on the fly, or generate a code path or some execution path to do some operation based on the annotations that are on our code. Then we went ahead and we looked at some examples of using some built-in annotations. We walked through some of the annotations that already exist in Java as part of the language itself, and we saw how those could be used to help us to write better Java code. Then we went ahead and we created our own annotation class. We saw how easy it is to structure an annotation class and some of the things that we might want to put into an annotation class when creating one. Then we took a little bit of a break here and we talked about an important concept in Java, reflection. And we didn't go really into depth into reflection, but we basically said reflection is this idea that code can examine itself while it's running and possibly modify itself. Then finally, using this knowledge of reflection and our annotation, we wrote some code to actually examine our annotation using reflection at runtime and do something. So that's the basic idea of annotations in Java. It's a very powerful concept that is underused, but you can do some pretty neat things using annotations, especially at runtime if you use reflection to pull up annotations, and you figure out how to use these things correctly, you can really save yourself a lot of tedious code, because you can write code that is able to operate off annotations and really save you a lot of common scaffolding code that you might write